Today we're going to talk about graphing what it says are simple rational functions. I want to be careful with that word simple and make sure we're on the same page for what it means here. It doesn't necessarily mean easy, so I don't want you to see that word simple and then be like, oh man, this is supposed to be simple. Okay, what it means by simple is that we're only going to be dealing with first powers of x today. Right? That's what it means by simple, and then as we get more complex, we could be dealing with higher powers of x, and we'll look at how that works in tomorrow's lesson. So don't take that word simple as meaning easy and then feel bad about yourself if it's difficult for you. It doesn't mean easy, it means just first powers of x's. Rational means fraction. So what we're going to be talking about in this chapter are fraction equations. So it could be, when it says p of x over q of x, any polynomial. So we could have all kinds of x's and x squareds and all that kind of stuff in there on both top and bottom. The most basic example is 1 over x. That's like as simple as it can be as far as the stuff that's in it. When we graph that equation of 1 over x, we get the graph that is to the right here. This graph is called a hyperbola, not to be confused with hyperbole from English class, which means what? An exaggeration beyond realistic. So my love is greater than the depths of the ocean or something, an exaggeration beyond realistic. This is hyperbola, okay? Hyperbola is a graph that has two branches, okay? Those branches are bordered by asymptotes. So we talked about asymptotes when we talked about our tangent graph. This asymptote is a graph, a line that forms the edges of the graph. So we have in this one a vertical asymptote like we saw in our tangent graphs. But we also have a horizontal asymptote here as well. So it's following along these lines that are kind of bordering it. It's not going to cross over them. It's just going to follow along those lines forever and ever and ever. And we get these two separate sections. For today's problems, when we're looking at just first powers of x, we are always going to have two opposite quadrants of each other. Okay? So they're always going to be in opposite quadrants diagonally across from each other today. We're going to consider some function transformations. When something is added or subtracted to the x, what does it do to the graph?
Moves it to the left or right.
Moves it to the left or right, and it goes opposite of the direction indicated by the sign. So x plus 3 is going to move this thing to the left 3 units. So what I'm going to do in my graph is go 3 spaces to the left, and I'm going to draw in an asymptote. It's a little hard to see. Grab a different color. Whole function do.
Yep.
And direct go down 1. So I'm going to go down 1, and I'm going to make these for our 2 branches. So then we just need to figure out where are these 2 branches, like in which 2 sections are they going to be. To do that, we're going to make an XY chart for the simpler form of the function, ignoring the stuff we've already taken care of. So we've already taken care of the plus 3, we've already taken care of the minus 1, so we're going to do y is equal to negative 2 over x. Then in our chart, I'm going to plug in negative 2, negative 1, 1, and 2 for x. Why did I skip 0?
Because it's 0.
Because I can't divide by 0. So if I plug 0 into this, I'd have a significant problem. Because negative 2 over 0 is something I can't actually do. So I'm skipping over it. And that's why we get these asymptotes, is because of a division by 0. And so that part of the graph just kind of blows up, and we get this asymptote there. Okay. So when I plug these in, if I plug in negative 2, I get 1. If I plug in negative 1, I get 2. If I plug in 1, I get negative 2. If I plug in 2, I get negative 1. I'm going to plot these points from the fake origin, from where our asymptotes meet. Not from the real origin as actual points, but from where these asymptotes are meeting each other. So from there, I'm going to go negative 2 up 1. Negative 1 up 2. Positive 1 down 2, and positive 2. And that shows me which 2 quadrants for our graph And we've drawn these curves that just kind of follow along those boundary lines. We still need to discuss the domain and range portion of the problem, but are there questions on creating the graph?
When you're going around in between them, where the line's supposed to go, I don't know how to explain it. Like once you go around those two dots, how close do the lines get to your face?
Okay, it's really hard to judge like exactly, so I'm not going to be super precise about that. Eventually, it's going to get like so close to that line that it is basically that line. But how quickly it approaches those asymptotes kind of varies with the problem. So just kind of in general, make it just kind of follow the path. And I'm not
Does
going
it
to.
stay in the line with the dot or the line like above them? Or like,
It'll stay right along those dotted lines.
okay.
When you got the -2 over x for y, did you just like take off the -1 and the +3 when you made the
Yep.
lines?
Yep. I just ignored the parts of the graph that create the shift because we already created the shift. Alright, so for domain and range, domain is possible x values. So there is one x value that will cause significant problems in the original function. So we are not allowed to divide by 0. So what would I plug into the original equation that would cause me to divide by 0? -3. If I plug -3 into the original equation, -3 plus 3 would be 0 on the bottom, and that would be a significant problem. So that means that x cannot be -3. In the graph, what do you notice happens at x is -3? At x is -3 in our graph, what do we have? An asymptote. Okay, so that asymptote is limiting out that point of the domain, saying it can't be this point. So what is limited out by the other asymptote? And which variable is that? Y. So our range is that y cannot be -1. This fraction will never be able to equal -1. Just won't happen. Okay, so we're going to have one value limited out of our domain and one value limited out of our range, and those are going to come from our asymptotes. So x equals -3 is an asymptote. That means we cannot have that as a part of our domain. And y equals -1 is our horizontal asymptote, and that means that we cannot have that as a part of our range.
Where do you get the x equals -3 and y equals -1?
From the location of the asymptotes. So the vertical asymptote is at x equals -3, and the horizontal asymptote is at y equals -1. So the location of those asymptotes will give you your domain and range. Because the graph will never equal those values because it'll never cross those lines. Which is the -1 due to the graph here? Oops.
To the right one.
To the right one. Which is the +2 due to the graph? Up 2. So I'm going to go to the right one and up 2, and I'm going to place my asymptotes. So right from there, we can know domain and range without even graphing. Domain and range come from the asymptotes. So our x asymptote, the one that crosses the x-axis where? At 1. So that means x can't be 1. Because if x was 1, that would make us divide by 0, and that is a problem. And the asymptote that crosses the y-axis crosses it where? 2. So that means y can't be 2.
How come we couldn't find that out earlier last time?
We could have, I just didn't. I just did the whole graph first. So we still need to do the rest of the graph this time to figure out where branches go. So to do that, we're going to use this reduced out form of the equation where we ignore the stuff that created the asymptotes because we've already dealt with those. in our chart. We can't plug in 0. I'm going to choose to do -3, -1, 1, and 3. Why do you think I did 3s instead of 2s this time?
Be cleaner.
So it divides out nicer. Okay, it doesn't matter. You can pick whatever numbers you want, except 0. You can't divide by 0. But you can pick anything else. So I just picked 3s this time because it's going to divide out nicer. So you can pick whatever numbers you want. If you don't mind dealing with the fractions, you can plug stuff in that'll give you fractions. Get -1, -3, 3, and 1. And I plot out these points not from the origin, but from where the asymptotes meet each other. So I go back 3 and down 1. Go back 1 and down 3. Forward 1 and up 3. Forward 3 and up 1. So that shows us which quadrants we have. And just drawing our curves that kind of connect those dots and follow the lines. We should have arrows at the end of all those because they do go on forever up and down and forever left and right. They just don't cross those asymptotes. Some of your homework problems are going to ask you to just identify the horizontal and vertical asymptotes and state the domain and range. You don't actually need to graph to do that. You can just look at these shifts that occur. So our domain and range are the values of where those asymptotes are. If you need to actually give the asymptotes are the same exact thing, but with the equals. Okay? The x equals is the vertical asymptote, and the y equals is the horizontal asymptote. Okay? So some of your problems just ask you to give your asymptotes and give the domain and range, and you actually don't even need to graph it. Okay? You get those values by what causes us to divide by 0, or thinking about our horizontal and vertical shifts. Okay. In those types of functions, we had only one x in the whole problem. Okay? It is possible that you can have x on both the top and the bottom of the fraction. Okay? So then we're going to have this kind of general form where we have kind of like a y equals mx plus b equation on top, but also on bottom. So x is on both top and bottom. For these ones, we will not be able to just think about shifting. Okay? Because which one would we shift for? There's something with x in the top and there's something with x in the bottom. So we won't be able to think about shifting here. Our vertical asymptote is going to be where the denominator equals 0, because dividing by 0 is still a no-no no matter what. So we're going to figure out what makes the bottom of this fraction equal to 0, and that will be our horizontal, or rather our vertical asymptote. The horizontal asymptote is going to be at the fraction of the coefficients of x. Okay, so we just kind of ignore the rest of it, the numbers that are in front of the x's, that will be our horizontal asymptote. I can't really explain why that's the horizontal asymptote without a little bit of calculus, so we're just going to let it go and say that's the rule. So our equations here are going to look like this. They have x's on both top and bottom. So we can't think about shifting. So our rules are for our vertical asymptote, we're going to set the denominator equal to 0. So I'm going to say 2x minus 4 has to equal 0. So 2x equals 4. And x equals 2 is my vertical asymptote. So in the graph, I'm going to go over to x is 2, and I'm going to put in that asymptote. That also restricts my domain, so x can't be 2. The rule for the horizontal asymptote is y equals a over c, where we just look at the coefficients in front of the x's. So we look at what's in front of the x's, which is 1/2. So So our horizontal asymptote is y equals 1/2. Add that into our graph. And that also limits our range so that y can't be 1/2. So again, some of your problems just ask you to find your asymptotes in your domain and range, and then that would be it. You wouldn't actually need to plot any points and create the graph. You can just set your denominator equal to 0, gives you your vertical, take the fraction of those coefficients of x, will give you your horizontal. Now to plot points on this, we can't reduce down the equation because we didn't think about shifting. So when we create our xy chart, we need to create it for the entire equation. We have to use the original equation. And I'm going to try to pick things that'll be fairly easy to plug in. So like if I plug in 0, 0 is fairly easy to plug into something. If I plug 0 in, I get -1/4. So 0, -1/4 is a point. And I told you that for this lesson, when we're dealing with just first powers of x, they're always going to be in opposite quadrants of each other. So I already know now my graph is going to look something like this. This is a fairly rough sketch, but I'm going to call that good enough.
Wait, wouldn't you have to put it on the asymptotes?
No, because we plugged it into the original equation without any shifting. So good question. In the last problem, when we were thinking about shifting, we then were doing an xy chart for a reduced equation. So then we wanted to plot from our asymptotes. On this one, we're plugging into the entire original function. So we want to plot that real true point as a real true x comma y, not according to shifting, because we didn't think about shifting this one. Good question.
So you just draw the graph.
Yep, so we just kind of sketch it in. Once you know where one of the points is, you know that today they're going to be in opposite quadrants of each other. So then you can just kind of sketch them in.
For the 0, 1/4, where'd you put it at?
0, -1/4 on the actual point of 0, -1/4. The actual x comma y point. And not the asymptote value. Alright, so for this one, vertical asymptotes exist where the denominator equals 0. So we're going to take 3x plus 3 equal to 0. So 3x is -3 and x is -1. So in my graph, I can plot that out. And can I also say that makes my domain. X can't be -1.
Can you go over that?
Yeah, our vertical asymptote exists where the denominator equals 0, because dividing by 0 is a problem. So we set the bottom of the fraction equal to 0, and that gives us where our vertical asymptote is, which is also what limits our domain. The rule for horizontal asymptote is that y is equal to a over c, the fraction of what's in front of the x's. So this time, that would be y is equal to 1/3. I can plot that into my graph. And I can also say that that is what's going to limit our range. Y can't be 1/3.
Is that y equals a over c?
Mm-hmm.
What is c?
A and c are the coefficients of x. So it's just the numbers in front of the x in the equation. Then to find a point on the graph, I'm going to plug a 0 into the original equation. So 0 minus 2, 3 times 0 plus 3, and I get -2/3. So that means the point 0, -2/3 is on the graph, and that's the actual point, 0, negative 2/3, not a shifted point. So 0, negative 2/3, about there, which then tells me that the graph must exist down in that sector. And since today they're always going to be in opposite diagonal sectors, it must be up in the other one.
The graph is the same thing, but it's negative 2/3, so I wouldn't stop that and move up.
You move
I did something weird.
Right.
So I moved over to here.
9.2 tonight. Make sure you notice that last group is multiples of 3. Make sure you pay attention to your directions because, again, some of them just ask you to find asymptotes in domain and range. Some of them ask you to graph. Some of them are matching. Right? So make sure that you pay attention to your directions.